Thank you for allowing me the opportunity to speak to you today. My name's Peter Ebenwaldner. I'm a business development manager looking after screens. I've been working in this field for a number of years now, and Boise's showing his graph before about the number of presentations that you've done formally in different events around the country. I guess we've done lots of them along the way, and we've done a lot of promotion to try and get this screen knowledge up there. Yeah, so I guess when this is showing you, and you've already seen other slides today from Rod, just showing old traditional screens. These are the things that we were looking at. I guess we were actually requested and approached initially to actually bring along a screen design that will actually be an improvement on this type of screens. These generally will have anywhere up to 100 millimetre in aperture size, allowing all the fish, anything to go through it, and blockages with debris. We've learnt some very good lessons along the way when we've been out talking to early adopters or irrigators, and then what we do know is that old traditional screens are generally a swear word to irrigators. They see screens that block continually, need manual cleaning. They decrease the efficiency and the performance of their intakes. So hence we were challenged with the ability to actually replace this type of screen with finer screens. Part of this process, we were actually tasked to actually, wherever possible, try to achieve protecting the full life cycle of a fish. We also go down to little turtles and platypus, which is also very important to our community, and frogs. Which we tend to just talk about fish, but there is a lot of aquatic life that we need to protect along the way. So as I said, we're going from 100 mil down to 200 mil in accordance with the guidelines that is established today. So I guess I just wanted to tell you quickly about what is a screen and what we define it as a modern screen. So we just saw those old traditional screens. A modern screen is a screen that actually has a good medium, so we're looking at 2 millimetre wedge wire, or in the guidelines you can go up to 3 millimetre perforated plate or woven wire. We also provide a larger surface area than what you'd actually see in an old traditional screen. We work on lower approach velocities. In talking to a lot of the pump manufacturers and suppliers throughout Australia, they will openly tell you the approach velocity or the velocity entering into a pump will range anywhere from 1 to 3 metres a second. So we're talking about a much lower approach velocity entering into our screen of less than 0.1 metre per second, which is quite significantly less. We also want a screen that's even flow distribution over the entire surface. There's no point having a hot spot on one part of the screen and the other one's a low, less than 0.1. We want it over the entire screen surface. We want a screen that's got an integrated cleaning system to prevent biofouling growing in and outside of the screen. So again, to make that screen clear. We've actually developed and released into the market over a number of years now various screen types and sizes, and they all have different applications. But cylinder screen is basically 2 cylinders attached to a common manifold, which you'll see a number of pictures as we go through this. So we call our T-screen. And then we have a cone screen where we use for low water levels. Site conditions, and these are the big things. And where most of our cost is in regards to funding and installing screens is actually because we're doing retrofits on old sites. So we refer to them as brownfield sites or retrofits. So this is showing different, hang on, I'll just go back one. No, this has got a different thing on the screen here. Anyway, main factors for screen adoption. So pretty much as Rod mentioned earlier, it's all about collaboration and communication. We need funding to fund these sites. We need to look at screen suitability and viability on these sites, and we've been approached on many occasions where we say, let's put a screen on this site, but it might have a 50 mil pipe and it might only extract half a megalitre a day. I mean, why would we spend lots of money on a site like that? These are the things that we need to always be mindful of. And what we do know is early adopters, you know, they are actually very protective of their environment, and they're wanting to help, and they are conscious about the environment. Just getting back to this, yeah, so we got the cat caught up now. So most of these old sites that we actually install on are retrofits, and that they have a lot of complexity associated with that. And we look at poorly maintained pumps, which we heard about earlier. We have all sorts of weather conditions. We've been through the COVID, we've been through the floods and multiple floods, which have actually causes lots of delays. We look at varying water depths and the inability to de-water a site. So we have to do installations where the water is up and we need to get into the water. So then we need divers, and so these are all the costs that just keep adding and adding to that. Getting access to the site, power availability. We're now doing lots of sites through the Northern Basin Toolkit where we're actually providing standalone power plants that are solar powered, running hydraulic power units. So these are all the things that we need to take into account. The integrity of the pumps, that's a really big one that Rod mentioned before. It's so important that you know, the equipment we start off as well. So once we put a screen on and it's an old screen, a pump that's going to fall apart, then when that fails, the first thing they'll say is, we never had a failure before you put the screen on. And so that we just have to be mindful of that. These sites are very remote. To bring crews out and mobilise to these sites is a fair amount of cost. I think you get the idea. So the other thing is listening and collaboration and communication. Once we actually engaged, the irrigators were asking for uninterrupted water supply. So that is the majority of or their livelihood. They want to make sure that we're delivering water to the farmers throughout their distribution channels. They want low maintenance. They want easy to maintain and operate. They wanted the ability to actually retract the screen out of the way, so if they felt uncomfortable with actually putting all their livelihood in our hands and putting a screen on, thinking that the screen might fail and then they wouldn't be able to extract water. So they wanted the ability to pull that away, and they also wanted, this is the things that they've asked for, so they wanted us to be able to provide a solution that they could actually simply pick up the entire pump in one lift and put it up on the bank for maintenance and repairs. So that was another condition that we had to follow. So these are the things that would be requested from these early adopters. And we wanted the ability to prevent back flushing and blockages of their screen. And what I can tell you is we've done lots of visits around the country and presentations, and we've spoken to many people on the side of a riverbank. And I've heard on many occasions that they've had blockages up to every 15 minutes. A pump will block and then they backflush. It's just crazy, and this has been going on for years like that, and they just think that is the norm, but we've actually replaced that, and we also protect the aquatic life. Yeah, so I guess these are some of the Australian initiatives that we've gone through, and we've installed cone screens, and this is actually sorry, let's go back one. Yeah, so this was the first site installed in 2018 in Kahuna, which is near our factory. It is a 600 megalitre per day gravity diversion, and I guess now we're in the 6th year of irrigation, and you know, it hasn't missed a beat, and it's continued to deliver the water to their farmers, and yeah, and I guess it's actually been a real a stepping stone for us to learn, and we continue to learn as we work through this process. This is another site, Trangi Nevertai irrigation scheme, and this has had another type of installation where it had a sloping floor going into the pump well, which this at the back of this pump station is some vertical axial flow pumps. So again, we had to deal with water levels, and then I'll just go one more picture, and then this is actually, so this is the 4 cone screens in the front here. You can see the tops of the cones. They have an integrated cleaning system, they have wedge wire, and they can draw the water right down to the base of the cone. So that's why we use these cone screens. We have a T-screen in there, and it's actually run off a diesel pump. Which will actually drive this screen system. And again, we're developing all these different solutions. We mentioned before about New Zealand. We've got screens over there, and we've been delivering them for a number of years now. This is before the water was put in and during the construction period. This is a site that is extracting or diverting 2,850 megalitres a day, or 33 cubics for those that want a conversion. And I guess it's complying with the newer guidelines. And this is with the water on, and I guess it's been reported as one of the largest fish screen structures. We've done a lot of research to try and find it. Is there anywhere else in the world that actually has a bigger site? But we're still to find that. Thank you. This is Tanandra, and this is just showing you the inclines and things that we need to deal with. This is actually have two actual flow pumps, and we put them in the troughs. And you can see the difficult terrain that we have to do to install them. Rod actually showed before that we connect 3 pumps up together with a common rail system for one rail and one screen, so again to reduce cost. Lifting these pumps up in one piece, putting them into and this is showing the installation when it's completed. What we've been working on, and every site is different, so every site has different size pumps, different lengths, different inclines, different water levels and the like. So what we've been working on of late, we've actually been able to, this is for a greenfield site. This is actually for a location called Sunday Creek, Lake Moodamere, near Rutherglen. And yeah, so they're actually, we've been able to work directly with a pump manufacturer. That pump manufacturer and us are actually designing the system where we're able to mount the rails directly onto the pump column. And they've agreed to do this together, and we're developing this in unison. So this will be a really good thing for going forward to actually save money. And that's what we're always looking for, is how we save cost. And that site's planned to be installed in Q1 of next year. This is showing a nice application for a fish. It's not being affected by the actual screen, and it'll just swim away. I guess the modern screen success, so we've actually been able to increase pump efficiencies, reduce energy costs, we've heard before, reliability of water delivery, and less damage to infrastructure. So just continue on. This is the screen team. We were talking about teams before, and I guess this all started with AWMA going back a number of years now, where Brett and received a call from Dr. Craig Boys and Dr. Martin Mellon Cooper and inquiring whether we could provide such a solution. So I guess, it goes back years, and we've developed a team all around this now. We've got happy irrigators and fish and anglers as well. There's a lot of research being done on the benefits received by farmers, and this can be shared through the fisheries guys. And I guess there is a set of guidelines. And I guess in summary, the world-class best practice screen technology is available here in Australia. Every installation is designed with the lowest cost, best screen solution in mind. As the industry evolves, lessons are learnt and implemented, and we're continuously on the progression of reducing cost, and we're always seeking ways to deliver a cost-effective, viable site. So thank you very much.